Problem Solved is supported by ACAM, a property management company serving the New York metro area and South Florida since 1983. Focusing exclusively on third-party property management, ACAM delivers a wide range of services, including capital project management, compliance, energy management, staff hospitality training, and industry-leading technology. To learn how ACAM can service your building, visit acam.com today. Welcome to Problem Solved, a conversation about problems that have been solved in New York's co-op and condo buildings. I'm Carol Ott, publisher and editor-in-chief of Habitat Magazine. My guest today is Darren Johnson, an account manager at Bright Power, a provider of energy and water management services for the real estate industry. One of the most challenging problems for co-ops and condos today is gauging the health of their building systems. It matters because if equipment is in poor health or not functioning properly, you'll get stuck when you try to bring your energy usage down. So most buildings have supers, and they take care of its equipment. I understand there is technology to help with that, so give me a sense of what is out there that will help a super and therefore a building owner.
Today, with the advancement in technology, there are wireless sensors that are attached to different pieces of equipment to monitor space temperature, water temperature, various different things inside of a building that normally can't be monitored on just an individual basis.
I've heard of something called BIS, the Building Information Systems, the thing that monitors your building systems. And now I've also heard about RTEM, which is real-time energy management. What's the difference?
BMS allows you to manipulate or change the settings on equipment. That is something that a site staff would use in case something came up, there was a service disruption or something changed and they needed to make an adjustment, and they can do it from their computer or they can do it from their cell phone. The traditional way is that site staff would manually make an adjustment to the equipment physically there in front of it. BMS allows you to do that remotely so that you don't have to be in the room where that piece of equipment is existing.
And that system has sensors.
It does, but usually those sensors are limited to the specific pieces of equipment that you are trying to manipulate. So you're going to have them on the more complex, larger pieces of equipment. Real-time energy management, or RTEM, they utilize those BMS sensors. That is a part of what real-time energy management is going to be tapping into, but it's also to be able to add further sensors. If you think about large buildings, you're going to have mechanical ventilation. You may have a cooling tower, a chiller, multiple boilers, much larger pumps and motors. You could have a cogeneration system or a separate domestic hot water system. A BMS is not going to be tied into all of that equipment and all of those systems. It's going to be very specific. What real-time energy management does, it leverages that BMS system and then expands upon it. You're creating a bigger network of information that you're monitoring outside of what the BMS is.
And tell me, what exactly am I going to get if I have installed an RTM service? What are we learning?
If you think about the old way, how you find out if equipment has failed, stopped working, or there's a service disruption, you have residents that call, maybe water temperature is too cold, it's too hot. What is the issue? But you find out after the fact. So everything is reactive. What real-time energy management allows you to do is you think about it from a big data standpoint. You're collecting a lot of information 24 hours a day, 7 days a week, year round. That allows an energy engineer to analyze that big data and to have a better, more thorough understanding of the performance of the building. And it allows you to create a benchmark to say, okay, this is where we are. So let's create some parameters around that performance benchmark. That way we can see if there's variations that take place so that you're going to be able to see before equipment starts to fail. And so it allows it to be almost predictive in the sense that you can see things that are happening. And so if there is a service disruption, it's going to be either eliminated if you catch it early enough, or it's going to be minimized so that it's not after the fact when something just fails completely.
Is the point of RTEM to tell you before equipment fails, or is the point of it that somebody does something with this data so you can say, I actually want to bring my energy profile down?
It's a combination of both. It's not only about minimizing and eliminating service disruptions, it's also to be able to optimize the performance. It allows you to identify inefficiencies. Let's say you have three boilers and all three boilers are running at some sort of varying time. But what you do with real time energy management is you identified, okay, I don't need all three boilers running. I only may need one and maybe two. And maybe the third can be alternated at some point in time. What are the recommendations that we can provide to the site staff to be able to say, okay, this adjustment needs to be made?
And is this system geared for only large buildings, or does it also work for smaller buildings?
It is appropriate for all size buildings. The service is going to be geared towards the size of the building and the complexity of the equipment and the systems that are in there. If you think about small buildings, most of them tend to have a heating plant and the boiler that's provided space heating and domestic hot water. So, what they may have as far as real time energy management is only a system that's specifically geared towards monitoring the heating plant. A lot of buildings in New York City is steam. So you might have indoor temperature sensors in a sampling of the apartments. You're monitoring the performance of the boiler. You're monitoring the domestic hot water. But it is still very useful because if you think about how you're going to be able to continue to reduce that and your carbon emission, you can have 75% of the energy that's associated with that one system. So it has a very practical application to smaller buildings. It's just that it's going to be a smaller scaled down version of what larger buildings would have installed.
And just give me an idea of cost of these kinds of systems when you're a small building or a large building.
The cost varies without a doubt. You may be talking about something that is potentially $500 to $700 a month, let's say, for a small building, where you're going to have somebody who is not site staff to have a partner that is going to be looking at this information and providing feedback. It could be anywhere from that range of $500 to $700 a month, all the way up to $1,500 to $2,000 a month, depending on the complexity and the size of the building and the installed equipment that you're monitoring. As you can imagine, the more that you're adding into the real-time energy management, then the more expense. And then there may be some services that are less. The question is, what is going to be the amount of interaction that you're going to be receiving? So, as with anything, you get what you pay for.
If I, as a board director, buy one of these RTM systems, monitor this for a year, and tighten up my ship, in essence, what is the next step? We're all operating efficiently, but still my carbon emissions are high. It's not going to tell me what's the next piece of equipment I should buy, or what should I replace in my building or revamp, correct?
It can. It depends on the partner that you have. If you have your energy engineer as your partner, then that engineer is going to help you think about what is that replacement equipment? How do you potentially reposition the building? Because everybody knows that the conversation today is about electrification. So the question for a lot of buildings may not be necessarily how do I electrify tomorrow, but how do I transition to electrifying in the future? And so this is information that an engineer is going to have that will be able to better provide that guidance. That is very important in order to be able to make the best decisions and to prudently invest in these type of large capital investments. When you spend that money in something that has a 20 or 30 year expected useful life, you want to make sure that you're more than confident that you have made the right decision.
Okay, thank you very much. Great food for thought, that's for sure.
You're welcome. Thank you.